The sun. This is pretty cool. It gave us a pretty hard smack yesterday. What are we talking about? A massive flare that shot out of the solar storm. It was the strongest solar flare this year. I want to bring in Jackie Jarris. You talk about weather on the Earth, but this is all about what's happening on the surface of the sun. Explain.
Right.
What is this actually?
But it affects us
Yeah,
eventually,
absolutely.
all right? We've already felt some impacts for this, but the big impact is going to come tomorrow. And there's two different things that we're talking about. We've got solar flares, and then what comes after it is what we call the CME. Let's roll the video, and I'll kind of explain the difference. And don't get too grossed out when I say this, because a solar flare, think of a solar flare as the sun shooting out like hot, stinky breath at you. And it's got all these little tiny particles that are charged that come at you. And what follows after, which doesn't happen every single time, is a CME, or a coronal mass ejection. And that's plasma, so that's more like hucking a loogie, sort of, at the Earth, okay? And they have different impacts. But this is the strongest one that we've seen in 5 years, and it's coming at the Earth at about 4 million miles per hour. So all these little particles then get caught up in the Earth's atmosphere and heads towards the poles. And why do we care about that? Well, we care about it because it affects our toys, our GPSs, it affects our satellite systems. We've already had outages and blackouts of high-frequency radio, and that has to do with the airplanes that are up towards the pole, okay? So they get interference in their communications, so they've already been rerouting some of the planes. Then we can get outages to the power grids, the GPS and satellite interruptions, but the one bonus is we get beautiful aurora borealis displays, and that is going to be coming tomorrow night. So keep that in mind. We've been in this really active phase, this solar cycle as we call it, and this little spot here is where that ejection has been taking place, and we could see more active flares like this, Suzanne, really in the next 1 to 2 weeks. That's kind of a problem.
So we're following this massive solar storm. The fallout could actually reach Earth today. We're talking about possible problems for satellites, power grids, navigation systems such as GPS. Meteorologist Rob Marciano joining us to break it down and explain. It sounds kind of scary.
Yeah, well, we're entering this period of solar activity that's going to be quite active, not just now, but going forward through next year. And the flare that happened Sunday night, and there was one that happened last Thursday, so it's happening quite often. The flare that happened Sunday night was pretty strong, at least the radiation of it was. And just to give you a reminder, when you have a sunspot, it emits a solar flare that has radiation with it. It also has charged particles, so it's a two-prong event, basically. The radiation gets here a little bit faster. That happened yesterday and last night. Matter of fact, some planes, they don't like to fly over the poles because, one, that messes with the radio communications, and two, the X-rays from this radiation, it's not, you don't want to get zapped with too many X-rays, so some planes were diverted because of that. Now, the charged particle, or this, what we call the coronal mass ejection, CME, travels at 1 million miles an hour, all right? So 93 million miles away, you do the math, it's coming at us right now. So this was not an X flare, thank goodness, but it's very, very close. If this was the next flare, this would be a major event that would trigger wide-scale blackouts. But they think there was an M9 flare, brief radio blackouts possible throughout the day today, and with the G3 type of storm, there might be some power outages in the spots, but it's more going to be a G2, G3. Spacecraft, NASA said they were cool with the ISS. They didn't have to do anything terribly drastic with the guys up there. So there's no need for you to go out and buy an iron vest or wear sunglasses today.
Iron Man.
But aurora borealis, the northern lights tonight,
right,
could very easily get into the lower 48. So keep an eye out tonight on the sky.
Okay, all those astronomers out there. Thanks. Thanks a lot.
An aurora is the polar light show produced by charged particles in the Earth's magnetic field. They're beautiful to see, but they're also a reminder that polar regions have the least protection against solar storms. So when a big blast of solar material heads towards Earth, that's precisely where it causes the most havoc. So commercial airlines reroute jets from flying in the North Pole region, where solar storms can disrupt or knock out high-frequency radio communications, cutting off pilots from air traffic control. Scientists have found that solar storms can cause GPS receivers to fail, which is a danger for jets flying in zero visibility weather or long-distance flights.
Now turn right.
But away from the polar regions where most of us live, it's not likely your car's GPS would malfunction, but high-precision GPS systems just might. That would compromise activities such as stabilizing a floating oil rig or pinpointing a distress call from a mobile phone. A bullseye impact on Earth could knock the power grid offline or produce rogue spikes in electrical currents, tripping key transmission lines or causing irreversible physical damage to large transformers. Scientists say all those things are unlikely, but what is likely is many people will be getting a nice light show. Jennifer Delgado, CNN, reporting.